as we venture into this mesmerizing world of anatomy, where the rhythm of life pulses through every beat of the heart, where arteries and veins paint a masterpiece of interconnected pathways, and where nerves conduct the symphony of motion. Today, we will unveil the cloistered marvels of blood flow within the heart and its interconnectedness to the rest of the canine body, including their organs, forelimbs and hind limbs, along with their arteries, veins, nerves, and pathways. This is Eliza Neil Marie C. Delara from Group 4, and welcome to our presentation. Let's begin.
Alright, so I'll be here discussing the pelvic viscera. It's a good day. The pelvic viscera resides within the pelvic, and this cavity is located within the um, part of the pelvis beneath the pelvic brim. Okay, so the pelvic viscera refers to the internal organs located within the pelvic cavity of the dog body. The pelvic cavity is the lower part of the abdomen, situated between the hip bone. It contains various important organs that plays essential roles in the production, exertion, and digestion. The pelvic viscera includes um, the urinary bladder. The urinary bladder is a hollow muscular organ that stores urine produced by the kidneys. It lies in the lower part of the pelvic cavity and is connected to the kidneys by two tubes called the uterus. The bladder expands to accommodate urine and contracts to expel it during urination. The uterus are two narrow tubes that connects each kidney to the urinary bladder. They transport urine from the kidneys to the bladder. And the third, the rectum. So the rectum is the final part of the large intestine. If it is a muscular tube that stores feces or waste products from digestions before they are eliminated from the body through the anus. And sigmoid colon. The sigmoid colon is the S-shaped portion of the large intestine that connects the descending colon to the rectum. It plays a role in further absorption of water and nutrients from the remaining digestive material. And next will be the reproductive organs. So we have here the uterus in females. The uterus is a pear-shaped organ where fertilized egg implants and develop during pregnancy. Ovaries in females, the ovaries are small, almond-shaped organs that produce eggs or ova. It secretes hormones like estrogen and progesterone. And the fallopian tube, also in female organ, the fallopian tube are two narrow tubes that connects the ovaries to the uterus. They serve as the pathway for the eggs to reach the uterus after ovulation. And the mastoid gland, the prostate gland. The prostate gland is a small walnut-sized gland that's below the bladder in males. It produces a fluid that combines with sperm to form semen during ejaculation. So, rectovesicle in males or rectourine in females. It's a pouch. These are peritoneal recesses between the rectum and the bladder in males, or in the uterus in females. And uterovesicle in females or rectourine in males. These are peritoneal recesses between the uterus in female or the rectum in males and the bladder. These pelvic viscera are essentials for various bodily functions, including urinary storage and elimination, digestion, and reproduction. They are situated within the pelvic cavity and are protected by the bony structure of the pelvis. Okay, thank you so much. So, hello, good day. I'll be discussing the basic functions of the heart, and yeah, let's go ahead and start. So it's the muscle at the center of a circulation system. It pumps blood around your body as your heart beats. This blood sends oxygenated nutrients to all parts of your body. and carries away unwanted carbon dioxide and waste product. So the blood flow through the heart begins with the oxygenated blood returning from the body to heart through two large veins called the cranial and caudal vena cava. So here's how the blood flows through the heart. Okay, so the oxygenated blood, the cranial and caudal vena cava, the oxygenated blood from the body enters the heart through the cranial and caudal vena cava. The cranial vena cava carries blood from the upper part of the body, while the caudal vena cava carries blood from the lower part of the body. Okay. So then next, the deoxygenated blood from the both cranial and caudal vena cava enters the right atrium, one of the four chambers of the heart. So it's the right atrium. And from the right atrium, the blood passes through the tricuspid valve, which separates the right atrium from the right ventricle. The tricuspid valve prevents the backflow of blood into the right atrium when the ventricle contracts. The blood flows into the right ventricle, the next chamber of the heart, so it will be in the right ventricle. From the right ventricle, the blood is pumped through the pulmonary valve into the pulmonary artery, which carries the deoxygenated blood to the lungs. So from pulmonary valve, it will go through the lungs. So in the lungs, there will be the blood undergoes gas exchange, where carbon dioxide is released and oxygen is absorbed, turning the blood oxygenated. So now, oxygenated blood returns from the lungs through the four pulmonary veins, or two from each lungs, the left atrium of the heart. So the oxygenated blood from the pulmonary veins enters the left atrium, the third chamber of the heart. So the left atrium is the third chamber of the heart. And next, um, from the left atrium, the blood passes through the mitral valve, also known as the bicuspid valve, which separates the left atrium from the left ventricle. So from the left ventricle, um, the oxygenated blood flows into the left ventricle. So the oxygenated blood flows into the left ventricle, the final chamber of the heart. So remember, the final chamber of the heart is the left ventricle. So the deoxygenated blood is pumped out of the heart through the aortic valve into the aorta. So the aorta is the largest artery in the body and carries oxygenated blood from the heart to supply the entire body with oxygenated the, and nutrients from the aorta. So the oxygenated blood continues its journey through the um, intricate network of arteries, the arterioles, capillaries, venules, and veins, delivering oxygen and nutrients to the tissues and organs through the body. And the oxygenated blood returns to the heart through the vena cavae, and the cycle repeats. So that will be all. Thank you.
Hi, it's me, Karen KPL Karya, and I would be the one to trace the blood flow from the heart to the heart itself, the lungs, the trachea, the esophagus, the diaphragm, and vice versa. So, before starting the vessels of the thoracic viscera, let me first introduce you to veins. So we are already familiar with the arteries which sends bloods away from the heart. So veins sends blood towards the heart. So normally, we know that pulmonary veins sends oxygenated blood from the lungs to the heart, but usually in the systemic circulation, veins sends deoxygenated blood from the viscera to the heart. Okay, so veins follow the same general course as arteries, although variations in their number and size, their course are more frequent than in arteries. So, arteries normally have accompanying veins called satellite veins or venae comitantes. They often take the same name as the artery they accompany. So, smaller satellite veins are mainly double, and larger and deep veins are mainly single. So systemic veins have thin walls or large lumen. And when pressure is low, blood flows slower than in the arteries. Generally, there is no pulse in venous systems, and movement of blood is dependent on pressure relation in thorax and muscular activity. So, contraction of muscles results in compression of veins, propelling blood to flow towards the heart. So, negative pressure during inspiration or inhalation and presence of semilunar valves. So, by the way, semilunar valves prevents backflow. Negative pressure during inhalation and pressure of semilunar valves augments the flow. So, veins farther from the heart contains the most valves. Okay? So, veins are divided into superficial and deep sets, and superficial are large and are clinically important for venipunctures or for drawing blood and injecting fluids. Next is superficial veins acts in cooling the blood as they communicate with deep veins and interconnecting venous plexuses. So when an animal is cold, plexuses and large superficial veins contract so that most blood from extremities must be returned via deep veins, and this process also prevents heat loss. So when an animal is warmed or during strenuous activity or work, superficial veins and interconnecting plexuses dilate and are plainly visible beneath skin in short-haired breeds or specimens. So dilation provides means of heat dissipation. So let's go. Let's start. Let us start with the heart. The heart gets its arterial supply from the right and left coronary artery and the circumflex branch. The right coronary artery is smaller than the left coronary artery and measures about 1.5 millimeters in diameter and 5 centimeters in length. It arises from the right sinus of the aorta and does a sweeping curve to the right and ventrocranially. It lies in the fat of the coronary groove, and the initial part is bounded by the pulmonary trunk. It is dorsally covered by the right auricle and supplies the bulk of parietal wall of the right ventricle. It does not ascend beyond its borders. It sends branches to the right atrium, like 4 to 9 branches, and the right marginal branch in particular, or the ramus marginalis dextra, is larger, longer, and more branched than others. It supplies the middle part of the right lateral ventricular wall at anastomosis with the atrial branches that arise from the circumflex branch of left coronary artery. RCA, or right coronary artery, branches into subsinusal interventricular branch, or the ramus interventricularis subsinosus. It is the continuation of the circumflex branch. It is 1 millimeter wide and 3.5 centimeters long. It has left, right, and septal branches. It is shorter than the paraconal, and terminal branches are at the junction of the middle and distal thirds of the ventricular mass. It may reach and extend beyond the apex of the heart. There are about 3 to 4 branches that supply adjacent musculature of the left ventricle. There are about 5 or 6 larger and longer branches that arborize in adjacent part of right ventricle. Septal branches supplies the narrow zone of interventricular septum that is adjacent to the subsinusal interventricular groove. The second branch of arterial supply of the heart is the left coronary artery, or the coronaria sinistra. The left coronary artery is a short trunk that measures 5 millimeters wide and 5 millimeters long. It terminates in the circumflex and paraconal interventricular branches. The left coronary artery, as mentioned, has a paraconal interventricular branch, or the ramus interventricularis paraconalis. It is 1.5 centimeters in diameter, 1.5 millimeters in width, and 7 centimeters long. It winds obliquely and distally from left to right across right ventricular border in paraconal interventricular groove. It extends around the apex of the heart. It has a left and right and also septal branches. The left ventricular branch are long and large. There are about 7 of them and they decrease in size towards the apex. They are free of superficial collateral branches. The right ventricular branches, or the rami ventricularis dextri, is short and form a small anastomose with the right coronary artery and the subsinusal interventricularis branch. There are about 5 of them and they supply a strip which is 2 centimeters wide of the right parietal ventricular wall adjacent to the paraconal interventricular groove. Its conal branch in particular, which is also the first branch, is prominent and it partly encircles the conus arteriosus. It anastomoses with the conal branch of the right coronary artery. The septal branch, or the ramus septalis, either arises as a paraconal interventricular branch or a terminal branch of left coronary artery, or from the aorta or the circumflex branch. It runs obliquely towards the apex and it leaves major and minor branches along its course. Its first half lies deep into the endocardium of right ventricle. The second half penetrates deeply into the septum. The 2 of them combined is the source of intramyocardial collaterals to other coronary branches in young dogs. Next is the circumflex branch, or the ramus circumflexus. It measures 1.5 centimeters in diameter and lies in the coronary groove as it extends to the left and winds dorsocaudally and to the right. It runs towards the apex and is known as subsinusal interventricular branch. It has ventricular and atrial branches, and in average there are about 5 branches. Next is the left marginal branch, or the ramus marginalis sinister. It is the longest branch and is adjacent and parallel to the subsinusal interventricular branch. It follows the left border ventrally on the surface of the left ventricle. The atrial branches supplies deep surface of left atrium, auricle, and the ventral part of interatrial septum. It is a small branch. The first branch in particular is the largest and anastomose with the right atrial vessel to the sinoauricular node. Next, let us go to the veins, or the system of drainage of the heart. First is the coronary sinus, or the sinus coroneus. It is a dilated terminal end of the great coronary vein. It is 5 to 8 millimeters in diameter and only 2 centimeters long. It lies in the fat of dorsodextra part of the coronary groove and ventral to the caudal vena cava. It may be partly covered by few muscle fibers from left atrium. The great cardiac vein, or the cordis magna, lies in the dorsal part of the coronary groove and circles the caudal surface of the heart from the left. It arises near the apex of the heart and ascends towards the base, or the paraconal interventricular groove. It collects numerous veins from ventricles and small twigs from left atrium. It terminates in the coronary sinus where the passage diameter increases threefold. Next is the the great cardiac vein is branched into 2. The dorsal vein of left ventricle and the oblique vein of the left atrium. The dorsal vein of the left ventricle, or the dorsalis ventriculi sinistrae, ascends near the apex of the heart. It is the largest vein that is draining the left ventricle chamber. Next is the oblique vein of the left atrium, or obliqua atriae sinistrae. It enters the coronary sinus dorsally after emerging from the deep to the pulmonary veins. Another one that is that is branched from the coronary sinus is the middle cardiac vein or the cordis media. It ascends into the subsinusal interventricular groove accompanied by the subsinusal interventricular artery. It collects tributaries from both ventricles and empties into the coronary sinus. Next is the right cardiac vein or the cordis dextrae. There are several of them. There are long and narrow vessels, and some are not paired. It ascends to the ventral part of the coronary groove from the right ventricle and usually empties into the right atrium directly. So it does not go through the coronary sinus. Next is the Thevesian veins. They are microscopic channels that is venule in size. It opens into every chamber of the heart and within the myocardium. It anastomoses with the coronary artery branches and other cardiac veins. When lesions develop, blood may flow in retrograde direction in valvulus veins. These veins in particular are often found in the right ventricle and right atrium. Next on the list is the arterial supply of the lungs. It's the arterial supply of the lungs and its veins or drainage system of the lungs. So the lungs is fed by the pulmonary trunk and the bronchoesophageal artery. So the pulmonary trunk or the truncus pulmonalis branches into our left and right artery. So the left pulmonary artery or the pulmonalis sinistra curves dorsally cranial to the vein from the cranial part of the cranial lobe that crosses lobar bronchus. The lobar branch, these are two branches that divides into segmental and subsegmental branches. These branches are generally parallel to subsegmental bronchi and named according to the bronchopulmonary segments that they feed or they supply. Next is the right pulmonary artery or the pulmonalis dextra. It is shorter than the left and lies within the pericardium. It runs caudally across the base of the heart from the left to the right. It passes several left lobar bronchi dorsal to the left lobar veins. There is a pulmonary lobar artery branch that trifurcates and supplies the three processes of the lobe. There is also the right cranial lobar artery, the right middle lobar bronchus, and the right middle lobar artery. Next is the bronchoesophageal artery. It arises from the right fifth intercostal artery. It crosses the left face of the esophagus and contributes esophageal branch before entering the root of the lungs as a bronchial artery. The bronchial artery supplies tracheobronchial lymph nodes, peribronchial connective tissue, and bronchial mucous membrane. It terminates in a capillary bed which is continuous with pulmonary artery. The drainage system of the lungs is the pulmonary veins and the bronchial veins. The pulmonary veins is the vein that drains all the blood that is distributed to the bronchial tree. There is one pulmonary vein on each lobe, at least one, but sometimes there are two on the right cranial lobe. These two anastomose to form a larger vein that receives the vein from the right middle lobe, where blood is returned to right lateral part of the left atrium by a large vein that measures 1 centimeters in diameter. The right caudal and accessory lobes blood are drained by the pulmonary lobar veins, which usually opens individually into the dorsum of left atrium. Next is the bronchial veins. These veins are only found at the hilus of the lungs. They empty into the azygos vein or the intercostal vein at the level of the 7th thoracic. Next would be the vessels of the esophagus. The arterial supply of the esophagus comes from the thyroid artery, the bronchoesophageal artery, and the dorsal intercostal artery. So, the thyroid artery originates from the brachiocephalic trunk that branch out into an internal thoracic artery, which also branch out into a left common carotid artery. So, in short, the thyroid artery is a branch of the left common carotid artery. So the thyroid artery supplies the cervical portion of the esophagus. It branches out further into the cranial and caudal thyroid artery. So the cranial part supplies the glandular mantle underlying the lamen of pharyngoesophageal phagium. Next is the caudal thyroid artery, which branches out into a left caudal thyroid artery, originates from the thoracic inlet region. It is a long but small descending branch. It anastomoses with the ascending branch from the bronchoesophageal artery. Bronchoesophageal artery is another artery that supplies blood to the esophagus. The esophageal portion is the main source of blood to the cranial two-thirds of the thoracic portions of the esophagus. Next is the dorsal intercostal artery. So this artery supplies the remaining part of the esophagus. Next are the veins of the esophagus. So the veins that attaches on the esophagus are satellite veins of the arteries. And then the veins from the thoracic portion empties into the azygos vein. Next, we'll be discussing the trachea. So, the trachea's arterial supply originates from a branch of the aortic arch, which is the brachiocephalic trunk, that further branches out further to two branches, which is the right internal thoracic artery and the common carotid artery. The common carotid artery branches out to cranial thyroid artery. Next would be the costo-cervical trunk, which branches out further to vertebral artery and the caudal thyroid artery. So the same thing with the esophagus. The satellite veins drains the blood from the trachea. Lastly, we'll be discussing the diaphragm. So the arterial supply of the diaphragm is the internal thoracic artery. The internal thoracic artery runs ventrally until the costal arc until a junction of the sternum. Then there it becomes the cranial epigastric artery and runs to the muscle of the diaphragm to supply it as musculophrenic artery. It perforates the rectus abdominis muscle at its most ventral aspect, and it becomes the cranial superficial epigastric artery, which is the terminal branch of this specific artery. The diaphragm is drained through the caudal vena cava via the renal vein. And that is all for the thoracic viscera. So to continue on with the abdominal viscera, blood supply or vessels, it will be discussed by Thora. So Thora, please take the stage.
It's Dora, and I am going to be talking about the abdominal viscera and blood supply to the abdominal viscera and how the organs in this abdominal viscera transport the deoxygenated blood back to the heart. So first, before talking about the abdominal viscera, we have to know what is the abdominal viscera. So the abdominal viscera refers to the organs and the structures that are located in the abdominal region. And here it is shown here. Okay, so we are going to be talking about the branches of abdominal aorta first. Because the abdominal aorta is the continuation of the aorta, and the abdominal aorta, it's the aorta that supplies blood to the organs in the abdominal region, and it has 8 main branches. As we can see here, there are lumbar arteries, celiac branch, craniomesenteric artery, common phrenical abdominal tract. Actually, it's and renal arteries, testicular ovarian arteries, and colonomesenteric arteries, and the circumflex iliac arteries. And we can see all of that in this picture shown here, and we will be talking about those in depth in the following pages. Okay, so lumbar arteries. Lumbar arteries are the one that supplies blood to the region around the lumbar vertebrae. And there are two types of lumbar arteries. They are spinal branches and dorsal branch. The spinal branch extends through the intervertebral foramen, which is the foramen that spinal cord passes through, and that surrounds the spinal cord. And the dorsal branch it's the one that extend dorsally and supplying the muscles and skin above the lumbar vertebrae. So this one is the it's gonna go through the intervertebral foramen, and this one it's the one that goes above, like dorsally, and supplying the muscles and skin above the lumbar vertebrae. So let's see the first branching of the abdominal aorta. That it's the celiac artery. And celiac artery has its own branches that it's going those branches are the one that supply blood to the surrounding organs in the abdominal viscera. So let's see the hepatic artery. Hepatic artery is the first branching of the celiac artery. If we trace to the left and a bit cranial, we can see here this is the hepatic artery that comes out of this celiac artery. So it has hepatic branches, and the hepatic branches supplies the liver, and we cannot see it. There is also a cystic artery that supplies blood to the gallbladder, and the right gastric artery. Right gastric artery, we can see it here. If we trace it from the celiac artery to the right and to the cranial, we can see right gastric artery, which will supply blood to the lesser curvature of the stomach, because obviously it goes along this lesser curvature, and this is the anastomosis of the left gastric artery, which we will be discussing in a while. And the other branch of the hepatic branch, it's gastroduodenal artery. Gastroduodenal artery, we can trace it from the celiac and then hepatic, and if we go just a little bit to this, just a little bit to the right, we can see gastroduodenal artery. So gastroduodenal artery that supply blood to the pylorus of the stomach, since we can see here it's supplying blood to the pylorus. And gastroduodenal artery has two branches that goes one to the cranial and one to the caudal. So the one that goes to the cranial is the right gastroepiploic artery, which is the anastomosis of the left gastroepiploic artery, if we trace it here, which is the branch of the splenic artery. Splenic artery here. Okay. So this right gastroepiploic artery, it supplies blood to the stomach and greater omentum, as we can see here. The way it flows, it's along the greater curvature of the stomach. Okay, so the caudal branch of gastroduodenal artery, it's cranial pancreaticoduodenal artery, and find the name of it, we can guess that it supplies blood to the pancreas, to be exact, the right lobe of the pancreas and the duodenum. And the other, now we're gonna see the other branching, the second branch of celiac artery, which is left gastric artery. Left gastric artery, isn't it familiar? Of course it is, because it is the anastomosis of the right gastric artery here, right gastric artery, which is the branch of hepatic artery. Okay, so left gastric artery, it is here, left gastric, right? This is one of the branches of celiac artery, and it goes across the body of the stomach, from the greater curvature to lesser curvature, and so that's why it's applying blood to both surfaces of the stomach, and it has like branches. Those are called esophageal branches, and they also supply blood to the esophagus. And we have also have splenic artery, which is the third branching of the celiac artery. And splenic artery goes to the right, and it has two branching, dorsal branches and ventral branches. Okay, so dorsal branches, as we can see here, they are short gastric arteries. Those are the ones. Those are the dorsal ones. The ventral ones would be on the side. So the dorsal branches they include short gastric artery that supplies blood to the stomach, this side of the stomach, and a left gastroepiphyseal artery. So we can see left gastroepiphyseal artery, which is the anastomosis, with the right gastroepiphyseal artery. So by the name of it, we can guess that this left gastroepiphyseal artery that supplies blood to the stomach. Okay, so this is the other view that we can see more, we can see better of short gastric arteries. Okay, we will see the third branching of the celiac artery, which is the craniomesenteric artery. Craniomesenteric artery, which is caudal to the celiac. And craniomesenteric artery has multiple branching of the arteries that supplies blood to the different organs in the of the abdominal viscera. So first, let's see the common trunk. The fact that it's named trunk, it's because more than one artery, the branching of more than one artery. So let's see the middle colic. So this is our cranial mesenteric. Wait, sorry. This is our cranial mesenteric artery, and if we trace it caudal and a bit to the right and up, we'll see this middle colic artery. So middle colic artery, if we trace it to the left, we will see that it is connected. It is anastomosis with the left colic artery of the caudal mesenteric artery. So by seeing this, we can see that cranial mesenteric and caudal mesenteric arteries are connected with each other. And here we can see the ileocolic artery, and ileocolic artery supplies blood to the ileum and sacrum and colon, and ascending colon to be exact, because if we can trace the blood flow here, and here we have right colic artery, which is the other branch of the craniomesenteric artery, and right colic artery, actually it's forming arcades here with ileocolic and middle artery. And the ileocolic artery, we can see that it has two it supplies blood to the both surfaces of the ileum by one branch is mesenteric ileal branch. Why is it mesenteric ileal branch? Because it's on the surface of the mesenteric surface, and that supplies blood to the ileum and also to the antimesenteric ileal surface. So it's supplying blood on both sides of the surface, in both surfaces. Okay, and here on the caudal part of this artery, craniomesenteric artery, we can also see caudal pancreaticoduodenal artery, that it's anastomosis with what we said earlier, cranial pancreaticoduodenal artery, and that supplies blood to the right lobe of the pancreas and the duodenum. Okay. So, the last thing that we have to talk about is about this artery is jejunal arteries, that are the caudal branches of craniomesenteric artery, and those jejunal branches supply blood to the jejunum. Then the other branching, the number 4 branching, is the common phrenico-abdominal trunk here. By the name of it, we can guess that this trunk may supply blood to phrenic meaning referring to the diaphragm, abdominal, something that has to do with abdominal. Okay, let's see. The first one is caudal phrenic artery. So caudal phrenic artery that supplies blood to the diaphragm, and caudal abdominal artery supplies blood to the abdominal wall. One thing that we have to know is that this caudal phrenic arteries also supplies blood to the adrenal glands, because adrenal glands receive blood from aorta or caudal phrenic, renal, or lamella arteries. So that's something that we have to know. And now here is our renal arteries. Renal arteries, when we say it, we have to know that it is paired because we have two kidneys, one in the right, one in the left, and the right renal artery, it's a little bit cranial than the left, since the right kidney is more cranial than the left kidney, and they leaves that's why it says it leaves the aorta as different levels. And yes, the left renal artery, it lines also to the caudal vena cava, and of course they both supply blood to the kidneys. Okay, let's go to our another branching of the abdominal aorta, which is testicular/ovarian arteries. So it depends on the gender of the animal. It is here. It's actually between the renal and external iliac artery, and they will be depending on the gender, like I said, and they are paired, meaning that both it has the right testicular and left testicular, right of ovarian and left ovarian. So ovarian artery arises halfway between the renal and external iliac arteries, and they that will varies in size, position, and tortuosity depending on the degree of the development of the uterus. And testicular artery leaves the aorta, and then it will be going to the ureter. Something that we have to know that is important surgically is that the left testicular and ovarian veins usually enter the left renal vein. That is about vein, but I just think it's really important for us to know. So okay, and here we have caudal mesenteric arteries. Caudal mesenteric artery, it's not paired, it is unpaired, and it arises near the termination of the aorta. So the termination of the aorta will happen at the bifurcation of the iliac arteries, external iliac arteries. And this caudal mesenteric has two main branches, let's just say prominent branches that we can see are cranial rectal artery and left colic artery. Left colic artery will supply blood to the descending colon, and cranial rectal artery will supply blood to the rectum, according to their names. It's also this left colic artery, well, it is also the anastomosis of the middle colic artery, as we can see here. Last but not least, we have deep circumflex iliac artery, and they are paired here. It is very close to the termination. It is just cranial to the termination of the aorta here, and it is paired both sides, and they supply to the skin of caudal abdominal area, the flank, and the cranial thigh. Okay. So those 8 branches of abdominal aorta are the those supplying blood to the organs in the abdominal viscera. So how the oxygenated blood from those organs travel back to the heart. So when we say deoxygenated blood, what we remember, what our memory will call us, is this called the vena cava. So let's just revise a little bit about this. Caudal vena cava, it drains to the right atrium, and it begins at the ventral surface of the L7. Since we are talking about the abdominal region, it's just a little fact about caudal vena cava. And all the dorsal intercostal veins, except for the first 3 dorsal intercostal veins on the right side, and for the dorsal intercostal veins on the left side, drains into the caudal vena cava in the lumbar region. Okay, so there are tributaries of Colavina Cava, just like there are tributaries of aorta. Okay, so we have seven large, prominent branches of Cordovina, tributaries of Cordovina Cava. They are lumbar veins, circumflexilar veins, right testicular ovarian veins, renal veins, hepatic veins, phrenic veins, phrenic abdominal trunk, which we have pretty much learned with the arteries. So, and most of them are the satellites of the corresponding arteries. So it's not going to be too complicated for veins. So let's see. When we talk about the transportation of the deoxygenated blood from the abdominal viscera back to the heart, we cannot leave this portal vein. So let's see, what is the portal vein? Portal vein, it's actually the portal vein is actually carried by the hepatoduodenal ligament to the liver, and it arises from the capillaries in the viscera and ends in the capillaries in the liver. So basically, portal vein carries blood from the abdominal viscera, and then it drains in the liver, and from the liver, via hepatic veins, the bloods are it's gonna drains into the column vena cava and then to the right atrium of the heart. So to be more exact, portal vein collects blood from pancreas, spleen, and the entire GI tract except for rectum and anus, and it lines deeply buried among the abdominal viscera. I think so. How portal vein was formed, and what are the large tributaries? So the portal vein is formed by the confluence of the cranial and caudal mesenteric veins, and its large tributaries are gastroduodenal, splenic, and right gastric veins. And the cranial mesenteric veins is always the largest vessel, and we will be discussing these in the coming slides. Okay, so let's see the tributaries of portal vein. We have cranial mesenteric vein and caudal mesenteric vein. When we're talking about the abdominal aorta, I hope you noticed that I traced the arteries from the cranial to the caudal. It's because the heart, it's cranial to the stomach. It's in the thoracic viscera, obviously. So yes, that's why I was talking from the cranial to the caudal direction, but now since the blood's gonna go back to the heart, we're going to be tracing the veins from the caudal region. Okay. So we have cranial mesenteric vein. So cranial mesenteric vein has multiple tributaries, and they include ileocholic vein, jejunal veins, ileal veins from the ileum, and caudal pancreaticoduodenal vein. Also include the right colic. So those veins, the tributaries of the cranial mesenteric vein, they carry blood collects blood from the jejunal vein, hence jejunum, ileal veins, hence ileum, caudal duodenum, hence caudal pancreaticoduodenal, hence pancreas and the duodenum, and the right lobe, yeah, of course, the right lobe of the pancreas, and the colon. And if we trace it here, this right colic branch of the right colic vein of the cranial mesenteric vein, it is anastomosis with, I mean, it's forming arcades with the branches of caudal mesenteric artery. So when we say caudal mesenteric artery, we can see two main branches. Also, let's see the tributaries of caudal mesenteric vein. So its tributaries include cranial rectal vein, left colic vein, and middle colic vein. Middle colic when we're talking about artery, middle colic it's in this side, but for the veins it's here on the left. We have to one thing we should know is that colon-mesenteric artery, it's not a satellite of the like named artery because this form the branches of craniomesenteric arteries, they are the satellites of their corresponding arteries. So yes, and colon-mesenteric artery, they receives blood from the rectum and the descending colon, the colon. And we will see the other two. So gastroduodenal vein. Gastroduodenal vein, it's if we go cranial, we will see this vein. Gastroduodenal vein enters the portal vein from the right side, near the body of pancreas, so here. And it drains into the pancreas, stomach, duodenum, and the right lobe of the pancreas because it has branches. And if we trace it here, we can see the one branch of the gastroduodenal vein, which is right gastroepiploic, which is anastomosis with left gastroepiploic, and they both are the satellites of their corresponding arteries. And gastroduodenal vein also have the other branch that goes caudal, which is the caudal, which is the cranial pancreatico-duodenal vein, which is the anastomosis, which is connecting with caudal pancreatico-duodenal vein. And that's why it says gastroduodenal vein drains the pancreas, stomach, duodenum, and right lobe of the pancreas. And then we have the splenic vein. So splenic vein receives blood from the spleen, stomach, pancreas, and the greater omentum. So let's see the branches of it. Splenic vein has a branch here, up cranial to the lesser curvature of the stomach, which is left gastric, which is so it drains blood from the stomach, and also one branch to the pancreas. That's why it drains blood from the pancreas. And since the left gastric, it's anastomosis with the right gastric, drains blood from drains blood from the greater omentum. Okay. So after talking about the main liver tributaries of the portal vein, we can move on to the another step after what happens after portal vein after finish collecting the deoxygenated blood from the abdominal viscera. So as shown in the chart, this is the chart that I drew myself for the learning process to be easier. So after receiving blood from the respective organs, portal vein enters the liver. And in the liver, upon entering the liver, it then branch in the liver into two branches, which are short right branch and the long left branch. The short right branch, it goes to the right lateral lobe of the liver and caudate process of the caudate lobe, and the long left to the other lobes. And within the liver, the portal vein, it's gonna joins the central hepatic vein, and then it rises into hepatic branches, and those hepatic veins leave the liver and joins finally to the caudal vena cava and to the eventually to the and since the caudal vena cava drains to the into the right atrium, that's how our the deoxygenated blood from the abdominal viscera, it's transported back to the heart. And that is all about the abdominal viscera and the blood supply, the arteries and the veins. And thank you for listening. My classmate Guinevere will be talking about the pelvic viscera in the next slide. So yes, thank you for listening.
All right, so I'll be here discussing the pelvic viscera. It's a good day. Yeah, so the pelvic viscera resides within the pelvic, and this cavity is located within the um, part of the pelvis beneath the pelvic brim. Okay, so the pelvic viscera refers to the internal organs located within the pelvic cavity of the dog body. The pelvic cavity is the lower part of the abdomen, situated between the hip bone. It contains various important organs that play essential roles in the production, exertion, and digestion. The pelvic viscera includes um, the urinary bladder. The urinary bladder is a hollow muscular organ that stores urine produced by the kidneys. It lies in the lower part of the pelvic cavity and is connected to the kidneys by two tubes called the uterus. The bladder expands to accommodate urine and contracts to expel it during urination. The uterus are two narrow tubes that connects each kidney to the urinary bladder. They transport urine from the kidneys to the bladder. And the third, the rectum. So the rectum is the final part of the large intestine. If it is a muscular tube that stores feces or waste products from digestions before they are eliminated from the body through the anus. And sigmoid colon. The sigmoid colon is the S-shaped portion of the large intestine that connects the descending colon to the rectum. It plays a role in further absorption of water and nutrients from the remaining digestive material. And next will be the reproductive organs. So we have here the uterus in females. The uterus is a pear-shaped organ where fertilized egg implants and develop during pregnancy. Ovaries in females, the ovaries are small, almond-shaped organs that produce eggs or ova. It secretes hormones like estrogen and progesterone. And the fallopian tube, also in female organ, the fallopian tube are two narrow tubes that connects the ovaries to the uterus. They serve as the pathway for the eggs to reach the uterus after ovulation. And the mastoid gland, I mean the prostate gland. The prostate gland is a small walnut-sized gland that's below the bladder in males. It produces a fluid that combines with sperm to form semen during ejaculation. So, rectovesicle in males or rectourine in females. To pouch, these are peritoneal recesses between the rectum and the bladder in males, or in the uterus in females. And uterovesicle in females, or rectourine in males. These are peritoneal recesses between the uterus in female or the rectum in males and the bladder. These pelvic viscera are essentials for various bodily functions, including urinary storage and elimination, digestion, and reproduction. They are situated within the pelvic cavity and are protected by the bony structure of the pelvis. Okay, thank you so much.
And now we are going to learn about the forelimbs major arteries and their branches with their functions. The subclavian artery or the arteria subclavia is a paired arterial vessel of the thorax. The left subclavian artery originates from the aortic arc beyond the level of the brachiocephalic trunk and passes obliquely to the left across the ventral surface of the esophagus. The branches of the right and left subclavian arteries are similar. The right subclavian arteries has four major branches: the arteria vertebralis, truncus costocervicalis, arteria thoracica interna, and the arteria cervicalis superficialis. Its function is circulating by distributing the blood from the heart to the forelimbs, neck, and thoracic area. So we have here their branches: the vertebral artery, internal thoracic artery, costocervical trunk, and the superficial cervical artery. First off, we have the vertebral artery or the arteria vertebralis. This is the first branch of the subclavian artery. It crosses the medial surface of the first rib and disappears dorsally between the longus colli and the scalenus muscles. It enters the transverse foramen of the six cervical vertebra and passes through the transverse foramina of the first six cervical vertebrae. It supplies both muscular branches of the cervical muscles and also spinal branches at each intervertebral foramen to the spinal cord and its coverings. At the level of the atlas, it terminates by entering the vertebral canal through the lateral vertebral foramen and continues to the vertebral spinal and the basilar arteries. Its function is to primarily distribute the vertebral artery to the spinal cord and the brain. Once it enters the skull through the foramen magnum, the vertebral artery joins with its counterpart from the opposite side to form the basilar artery. The basilar artery then provides blood to the various structures in the brain. The costocervical trunk, or the truncus costocervicalis, is a small branch of the subclavian artery that arises distally to the vertebral artery, crosses its lateral side, and extends dorsally as far as the vertebral end of the first rib. By its various branches, it supplies the structures of the first, second, and third intercostal spaces, the muscles at the base of the neck, and the muscles dorsal to the first few thoracic vertebrae. Its function is to supply the muscles, vertebrae, and skin in the neck region. The internal thoracic artery, or the arteria thoracica interna, leaves the caudoventral surface of the subclavian artery opposite the origin of the superficial cervical artery. It courses ventrocaudally in the cranial mediasternum and disappears deep to the cranial border of the transversus thoracic muscles. It supplies many branches to the surrounding structures: the phrenic nerve, the thymus, the mediasternal clunae, and the dorsal intercostal spaces. Its function is to distribute blood to the intercostal spaces, intercostal muscles, overlying skin, pericardium, and the diaphragm. Next up, we would have the superficial cervical artery. The arteria cervicalis superficialis is a long, meandering artery that lies in the angle between the shoulder and the neck, also formerly called as the omocervical trunk. It arises from the subclavian opposite the origin of the internal thoracic artery, medial to the first rib. It emerges from the thoracic inlet to supply the base of the neck and the adjacent subscapular region. Its function is to supply blood to the neck muscles, skin, and other superficial structures. Next, we have the axillary artery or the arteria axillaris. It is the continuation of the subclavian and extends from the first rib to the conjoined tendons of the teres major and latissimus dorsi. Its function is to supply the structure of the shoulder and continues as the brachial artery. So we have here its parts: the external thoracic artery, lateral thoracic artery, subscapular artery, thoracodorsal artery, caudal circumflex humeral artery, circumflex scapular artery, and the cranial circumflex humeral artery. First to discuss is the external thoracic artery or the arteria thoracica externa. This is usually the first branch of the axillary artery. It leaves the axillary near its origin. The external thoracic artery curves around the craniomedial border of the deep pectoral with a nerve to the superficial pectorals and is distributed almost entirely to the superficial pectorals. It may arise from a common trunk with the lateral thoracic artery, or it may arise from the deltoid branch of the superficial cervical artery. Its function is to supply blood to the external intercostal muscles and other muscles of the thoracic origin and region. Next up, we have the lateral thoracic artery, or the arteria thoracica lateralis. It arises from the caudal surface of the artery, approximately 2 centimeter from the cranial border of the first rib. This runs caudally across the lateral surface of the axillary lymph node and along the dorsal border of the deep pectoral ventral to the latissimus dorsi. It usually arises from the axillary artery distal to the external thoracic. The vessel may arise distal to the subscapular artery. Its function is to supply blood to the serratus ventralis muscle, pectoral muscle, and the mammary gland. The subscapular artery, or the anteria subscapularis, is larger than the continuation of the axillary in the brachium. It passes caudodorsally between the subscapularis and the teres major and becomes subcutaneous near the caudal angle of the scapula. Each bone is supplied by at least one main artery, which enters through the nutrient foramen in the cortex of the bone. The nutrient artery is a branch of an adjacent artery, which for the scapula is a subscapular artery. It contributes blood to the muscles of the shoulder region, including the latissimus dorsi and the muscles of the scapula. It ensures the proper oxygen and nutrient supplies to the three muscles, contributing to their functions and maintenance. We have here the thoracodorsal artery, or the arteria thoracodorsalis. It is a large artery that leaves the caudal surface of the subscapular artery less than 1 centimeter from its origin. It supplies a part of the teres major and latissimus dorsi and ends in the skin. It is readily seen on the deep surface of the latissimus dorsi. It primarily distributes to the latissimus dorsi muscles and may also contribute to the blood supply of the overlying skin in the region. The caudal circumflex humeral artery, or the arteria circumflexa humeri caudalis, is the principal source of blood to all four heads of the large bicep muscles. It leaves the subscapular opposite the thoracodorsal and courses laterally between the head of the humerus and the teres major. It primarily supplies the deltoid muscles and surrounding structures in the shoulder region. Next up, we have the circumflex scapular artery, or the arteria circumflexa scapulae. This is a small vessel that leaves the cranial surface of the subscapular artery and extending obliquely dorsocranially between the subscapularis muscle medially and long head of the triceps muscles laterally. Reaches the caudal border of the scapula near its middle. This primarily supplies the muscles and tissues around the scapula. Here we have the cranial circumflex humeral artery, or the arteria circumflexa humeri cranialis. This is usually the last branch of the axillary artery before the axillary becomes the brachial artery. It arises from the axillary artery distal or proximal to the subscapular artery. It courses cranially to support and supply the biceps brachii and the joint capsule of the shoulders. It primarily supplies the deltoid muscles and surrounding structures in the cranial part of the shoulder region. Next up, we have the brachial artery. This is a continuation of the axillary from the continued and conjoined tendons of the teres major and latissimus dorsi. It courses distally across the body of the humerus to reach the craniomedial surface of the elbow, where it gives rise to several branches. The deep brachial and bicipital arteries are muscular branches of the brachial in the arm. The branches are the collateral ulnar, superficial brachial, transverse cubital, and deep antebrachial arteries. The brachial artery continues into the proximal forearm and gives off its branches, the common interosseous followed by a smaller deep antebrachial artery given off the median artery. The brachial artery is a blood vessel that supplies blood to the arm, forearm, and the hand. So as you can see here, here are the lists of the branches of the brachial artery. So first, we would like to discuss to you the collateral ulnar artery or the arteria collateralis ulnaris. This is usually the first branch that runs procomocaudally to enter the medial surface of the triceps muscles. This is caudal branch of the brachial and distal third of the arm. It supplies the triceps, the ulnar nerve, and the elbow. This primarily supplies blood to the muscles, skin, and other tissues of the forearm. Next up, we have the deep brachial artery or the arteria brachialis profunda. This leaves the caudal side of the brachial artery in the proximal third of the arm. Occasionally, this artery is double. It primarily supplies oxygenated blood to the muscles of the arm, including the triceps brachii muscles. Next up, we have the bicipital artery of the Next up, we have the bicipital artery or the arteria bicipitalis. This is a muscular branch of the brachial in the arm. It is frequently called the muscular ramus to the biceps brachii muscles. It supplies blood to the biceps brachii muscles, which is located at the front of the upper limb. The superficial brachial artery, or the arteria brachialis superficialis, loops around the cranial surface of the distal end of the biceps brachii, deep to the cephalic vein. It continues in the forearm as a cranial superficial antebrachial artery. Medial and lateral rami arises from the latter, and both course distally on either side of the cephalic vein, accompanied by the medial and lateral branches of the superficial radial nerve. These vessels supply blood to the dorsum of the forepaw via the dorsal common digital arteries. It primarily supports blood to the muscles, skin, and other tissues of the forelimb. The transverse cubital artery, or the arteria transversa cubiti, formerly called as the distal collateral radial artery, arises from the lateral surface of the brachial artery. Approximately 1 centimeter before that vessel runs deep to the pronator teres muscle. Its function is to provide blood supply to the tissues in the area of the elbow joint. The last one would be the common interosseous artery or the arteria interossea communis. This is the largest branch of the brachial artery as it is approximately 3 millimeter in diameter and 1 centimeter long. It primarily supplies blood to the muscles, ligaments, and other structures in the forearm.
So Janelle discussed the common interosseous artery. Just to add some information, it is the last branch of the brachial artery and it dives through the interosseous space within the radius of the ulna. The common interosseous has its own branches. Its branches are divided into cranial interosseous, caudal interosseous, ulnar artery, and deep antebrachial artery. So first branch we have the cranial interosseous. It is a small vessel that emerges laterally from the interosseous space. As you can see, this is the cranial interosseous artery. Um, it continues in the direction of the common interosseous artery after the caudal interosseous artery arises. It passes through the proximal part of the interosseous space cranially to supply the muscles, lying laterally and cranially in the forearm. Second branch, we have the caudal interrogus, and this is the caudal interrogus. You can see it lies between the opposed surfaces of the radius and the ulna. It supplies many small branches to adjusted structures. It passes through the lateral side of the carpal canal and in the carpal metacarpal joint, and it joins with branches of the radial and the median arteries to form arches that supply the pelvic surface of the forepaw. Next up, we have the ulnar artery. As you can see, this is the ulnar artery. It is formally called as the accessory interosseous artery in the dog, and it accompanies the ulnar nerve in the antebrachium, and we can expose this by separating the humeral from the ulnar head of the deep digital flexor muscle. It supplies the ulnar and humeral heads of the deep digital flexor and the flexor carpi ulnaris. Next, the last branch of common interosseous is the deep antebrachial artery. This arises from the palmar surface of the median artery, approximately 1 centimeter distal to the origin of the common interosseous artery. You can see, this is a deep antebrachial artery. This is the common interosseous artery. This supplies the flexor carpi radialis, the deep digital flexor, the flexor carpi ulnaris, and the superficial digital flexor. So I think that's it for the common interosseous branches, and thank you.
So let's proceed to the major arteries and their branches with their functions in the hind limb. The abdominal aorta gives off the paired external iliac arteries to pelvic limbs and terminates in the paired internal iliac arteries and the median sacral artery. The abdominal aorta divides into the common iliac arteries. The two branches of the common iliac arteries are the internal iliac artery supplying the pelvic area and the external iliac which supplies the lower limb. And here are the external iliac arteries branches. First is the external iliac artery. Second is the deep femoral artery, caudal epigastric artery, medial circumflex femoral artery, caudal abdominal artery, and cremasteric artery. So for the external iliac artery, the Latin name for that is iliaca externa, is the largest parietal branch of the abdominal aorta. And the function of external iliac artery is the chief source of blood supply to the legs. Its branches also supply blood to the lower abdominal wall. And as you can see in the screen, the highlighted one is the external iliac artery. The second one is the deep femoral artery, and the Latin name is profunda femoris. Is approximately 3 cm long, with approximately half of it lying within the abdomen and half outside. The function for the deep femoral artery, it supplies blood to the femur, hip buttocks, and tissues deep in the thigh. Next one is the caudal epigastric artery, and the Latin for that is truncus pudendoepigastricus. Is short and may extend to the deep abdominal inguinal ring before bifurcating terminally. And the function of the caudal epigastric artery is a blood vessel that carries oxygen-rich blood in your abdomen or belly. It is one of 3 epigastric arteries that supply blood to your abdominal muscles, which probably call your abs. Second, and the next one is the medial circumflex femoral artery, and the Latin name is circumflexa medialis. Is the continuation of the deep femoral artery beyond the vascular lacuna. And the function for the medial circumflex femoral artery, it supplies the
adductors and hamstring group, as well as the sciatic nerve and femoral head and neck through the anastomosis. The next one is the caudal abdominal artery, and the Latin name for that is abdominalis caudalis. It's a small vessel that usually arises from the cranial surface of the external iliac artery just after the deep femoral artery arises, but it may arise from the deep femoral, the podendoepigastric trunk, or the caudal epigastric artery. And the function for the caudal abdominal artery is it is a blood supply of the tail. Last but not the least of the external iliac artery is the cremasteric artery. The Latin name is the cremasterica. It's a small branch of the caudal abdominal artery, or the podendoepigastric, or the trunk runs toward the inguinal canal and supplies the fat lying around the deep inguinal ring. And the function of the cremasteric artery is a branch of the inferior epigastric artery along with anastomic flow from the other arteries supplying the scrotum provides blood flow to the muscles. So let's proceed to the femoral artery branches. The first femoral artery branches is the femoral artery. Next is the superficial circumflex iliac artery, lateral circumflex femoral artery, proximal caudal femoral artery, saphenous artery, descending genicular artery, middle caudal femoral artery, distal caudal femoral artery. So let's start with the femoral artery, and the Latin name is femoralis. Continues the external iliac artery from the vascular lacuna through the thigh. It in turn is continued caudal to the stifle joint by the popliteal artery. And the function of the femoral artery is to carry oxygenated blood to each of your legs. The next one is superficial circumflex iliac artery, and the Latin name is circumflexa ilium superficialis. It's a small artery that runs dorsocranially over the medial surface of the embrectus femoris to reach the septum caudal belly of the sartorius. The function of superficial circumflex iliac artery is the smallest cutaneous branch of the femoral artery. It contributes to the arterial supply of the anterolateral abdominal wall of the groin. The next one is the lateral circumflex femoral artery, or the Latin name is circumflexa femoris lateralis. It is a branch runs proximally and anastomosis with the superficial part of the deep circumflex iliac and the lateral circumflex femoral arteries. And the function for the lateral femoral circumflex artery, it supplies oxygenated blood to the anterior or front and the middle portions of the thigh muscles. It typically branches off from the deep femoral artery, although in minority of cases, 15%, it arises directly from the femoral artery. The next one is proximal caudal femoral artery, or the Latin name is caudalis femoris. It leaves the caudal side of the femoral artery, extends this to caudally, and crosses the insertion of the pectinus and then the adductor muscles. The function of the proximal caudal femoral artery is the second branch from the femoral artery, branching at the mid-thigh region and supplying the pectinus, adductor muscles, and gracilis. The third branch is the saphenous artery, or the Latin name is the safina. It is less than 1 millimeter in diameter, arises from the medial surface of the femoral artery just before the femoral artery disappears deep to the semimembranosus. And the function for the saphenous artery is it is which arises proximal to the stifle and supplies the skin on the medial aspect of the stifle. The saphenous artery accompanies the saphenous nerve and the upper third and the medial aspect of the leg, and anastomosis with the perforating branches of the posterior tibial arteries in the subcutaneous tissue. The next one is descending genicular artery, or genus descendens in Latin. It runs distally between the vastus medialis and the semimembranosus muscle to the medial surface of the stifle joint. And the function for the descending genicular artery is one of the arteries of the knee joint and participates in the vascularization of the superomedial structures of the knee, including the patella network. Next is the middle caudal femoral artery, or caudalis femoris media in Latin. It runs caudodistally and ramifies in the M. semimembranosus. And the function for the middle caudal artery is it is supplying the distal parts of the adductor and semimembranosus muscles. So now let's proceed to the last branch of the femoral artery. The distal caudal femoral artery, or caudalis femoris media in Latin, arises from the caudolateral surface of the femoral artery approximately 1 cm proximal to the entrance of the femoral artery between the heads of the M. gastrocnemius to become the popliteal artery. And the function of distal caudal femoral artery is, which is the last branch of the femoral artery, as I said, before it becomes the popliteal artery. It supplies the bicep femoris, semimembranosus, semitendinosus, and gastrocnemius, and the digital flexors. So that's it for the external and femoral arteries.
Okay, so next to the femoral arteries, we have the popliteal artery, which I will continue discussing. The popliteal arteries have its branches, which are the popliteal artery, the cerebral artery, the caudal and cranial tibial artery. First to discuss is the popliteal artery. It begins by passing between the heads of the gastrocnemius and terminates in the interosseous space between the tibia and the fibula distal to their heads. It is the continuation of the femoral through the popliteal fossa. So there are numbers of small genicular arteries branch from the popliteal artery, which are the following. We have the middle artery, the genicular artery, the lateral proximal artery, and the distal genicular artery. They supply the joint capsule, including the cruciate and collateral ligaments. These also are the caudal vessels, provide the large blood vessel to the stifle joint. Next is the cerebral arteries. These are muscular branches to the muscles of the caudal aspect of the crus. This also represented by the two branches of the gastrocnemius muscle, which also go to the collateral ligament, and by a branch that leaves the caudal surface to the popliteal artery and runs to the caudal surface of the popliteal muscle. Before the popliteal artery terminates, it gives a branch of small and proximal tibiofibular joint capsule, which continues beyond this to descend in the flexor digitorum lateralis muscle. Next up is the caudal tibial artery. The caudal tibial artery is another branch of the popliteal artery that descends along the back
of the leg, supplying blood to the muscles and tissues in the caudal or the rear aspects of the limb. So the small caudal tibial artery leaves the caudal surface of the popliteal artery at the introitious space and enters the flexor digitorum muscle, and it also runs distally in the muscle, giving off the medial and lateral branches. It supplies the nutrient artery of the tibia, which enters in the nutrient foramen of the caudal surface near the lateral border at the junction of the proximal and the middle third of the tibia. Lastly, we have the cranial tibial artery, which is located here. It is also arising from the popliteal artery. The cranial tibial artery travels down to the leg or the cranial aspect and provides blood to the muscles and tissues on that region. The cranial tibial artery continues the popliteal artery between the tibia and the fibula as well, after the caudal tibia artery arise. It is larger than the caudal tibial artery and inclines laterally as it runs distally. It crosses deep in the fibularis muscle longus to gain the deep surface of the long digital extensor muscle. Here it is partly separated from the bone by the small flat extensor muscle, which lies lateral to the artery. Now we're done with the popliteal artery. Let's proceed to the arteries of the hind paw. We have the branches of the hind paws are the dorsal pedal artery, the arcuate artery, the middle and lateral plantar arteries, the dorsal common digital arteries 2 to 4, the abaxial and axial dorsal proper digital arteries, common digital arteries 1, also the digital metatarsal arteries 2 to 4, axial and abaxial dorsal proper digital arteries 2 to 4 as well, the plantar common digital arteries 2 to 4, and the plantar metatarsal arteries 2 to 4, and lastly we have the axial and abaxial plantar proper digital arteries. First to discuss is the dorsal pedal artery. It is the continuation of the anterior tibial artery, which is located here. As you can see in the picture, the dorsal pedal artery is carefully palpated and identified along the entire course. This artery usually passes between the metatarsal 2 and 3, and the optimal site of the catheterization is most distal point where it can still be palpated. The dorsal pedal artery supplies oxygen and nutrients to the skin, muscles, and other tissues on the dorsal side of the foot and the digits. It is an important vessel for maintaining proper blood circulation and overall functions of the foot. So next we have the arcuate artery, which also run along the dorsal side of the foot and provides arterial blood supply to the adjacent muscles of the foot, which is the metatarsal bone and the toes 2, 3, and the 4th. It sends the 2 or 3 branches proximally to be distributed to the deep structure of the flexor surface of the tarsus. Next, we have the medial and lateral plantar arteries. These arteries are essential for delivering oxygen and nutrients to the to the tissues of the bones hind paw, helping to maintain their proper functions and health. To define the medial plantar artery, it is a branch of the posterior tibial artery. It runs along the side or the medial aspect of the hind limb and supply the blood to the medial or the inner structure of the paw, including the muscle, the skin, and other tissues. The lateral plantar artery is also a branch of the posterior tibial artery. It travels along the outside or the lateral aspect of the hind limb and provides the blood to the lateral structure of the paw. This includes the muscle, also the skin and other tissues. Next, we have the dorsal common digital arteries 2, 3, and 4. These arteries plays a crucial role in delivering oxygen and nutrients to the tissues of the digits, supporting their proper functions and health. If any of these are damaged or obstruction, it can lead to circulation issues and potentially affect the well-being of the dog's toes. This dorsal common digital arteries 2 to 4 arise cutaneously over the tendons of the long digital extensor muscle from the small trunk formed by the anastomosis of the cranial branch of the superficial branch of the cranial tibial arteries. These arteries arise from the main digital artery and run along the back of the dorsal surface of the metatarsus lower part, which is the lower part of the hind limb, towards the toes. Next, we have the abaxial and axial dorsal proper digital arteries 1. These are located on the back of the paw, while the axial dorsal arteries run along to the central part. This arteries plays a crucial role in supplying blood to the digital or the toes of the dog's paw, providing oxygen and nutrients to the tissues. Next, we have the dorsal common digital artery 1. It comes from the cranial branch of the Stephanus artery. This arteries plays a crucial role in supplying blood to the digital toe of the dog's paw as well. Next, we have the dorsal common, the dorsal metatarsal arteries. These are arteries responsible for supplying blood to the dorsal or the top part of the metatarsal region, which is the area between the ankle and the toes. These are similar to the comparable arteries of the forepaw, which side note, there are no first dorsal metatarsal artery is present, even if a first digit exists. Dorsal metatarsal arteries 2 to 4 arise from the arcuate artery and the terminal branch of the dorsal pedal artery in the proximal metatarsus. Next, we have the axial and abaxial dorsal proper digital arteries 2, 3, and 4. The axial dorsal proper digital arteries runs along the central part of the digits or the toes on the top side. The abaxial dorsal proper digit artery are located in the back or the abaxial side of the digits or the toes. Next, we have the plantar common digital arteries 2 to 4 as well. This is located here near the tendon of the flexor digitorum superficialis muscle. These arteries are located on the plantar side as well, and are part of the vascular system that provides oxygen and nutrients to the tissues in the dog's hind paw. These arteries are branches of the lateral plantar artery, which is part of the plantar arterial network responsible for providing blood to the paw and the plantar surface of the hind limb. As the lateral plantar artery travels along to the lateral side of the hind limb, it gives off smaller branches that supplies blood to the individual digits. These arteries, in turn, deliver oxygen and nutrients to the tissues of each toes, supporting their normal function and health. Next, we have the plantar metatarsal arteries. Um, Plantar metatarsal artery 2 is which supplies the blood to the second metatarsal region, which correspond to the second toe of the hind limb. And these arteries are branches of the lateral plantar as well, which is part of the plantar plantar arterial network, responsible also, same as the common digital arteries, responsible for providing blood to the paw and the plantar surface of the hind limb. Next, lastly, we have the axial and abaxial plantar proper digital arteries. Axial plantar proper digital artery, this would refer to the main or the central artery that runs along the central axis of the plantar aspect of the dog's toe. The axial artery will be closer to the central line of the toe, while in the axial plantar proper digital artery would be located away from the central axis of the toe, more towards the side opposite to the center line. So I think that's it for the arteries of the hind paw.
Here we have the forelimbs major veins and their tributaries. So essentially, the layout of the veins is similar in all domestic species. The venous drainage is in animals can be roughly divided into deep and superficial. The deep veins are just satellite vessels to the arteries that have been previously described. So first, I'm gonna discuss about the superficial veins of the thoracic limb. It consists of the cephalic vein, the median cubital vein, the axillary brachial vein, and the omobrachial vein. So the main superficial vein is the cephalic vein, or what we call the vena cephalica. It is a tributary of the external jugular vein, and it is the only large superficial vein of the thoracic limb. This vein arises. This vein arises from the radial vein at the medial palmar surface of the carpus, and it receives tributaries from the antebrachial region, including the median cephalic vein. Next is the median cubital vein, or what we call the vena mediana cubital. This one. This extends between the brachial or superficial brachial vein at the flexor angle of the elbow joint and the cephalic vein of the arm. It is approximately 2 millimeters in diameter and 2 centimeters long, and it crosses the distal end of the biceps brachii muscle obliquely as it runs proximal lateral to anastomose with the cephalic vein near the lateral border of the biceps muscle. It receives its tributary from the median antebrachial vein. Next, the third superficial vein is the axillary brachial vein, or what we call the vena axillary brachialis. It is formally considered a continuation of the cephalic vein. It courses over the lateral head of the triceps muscle and at the end of our main, or should I say, at the distal border of the lentiolus muscle, passes caudal to the humerus. It receives large tributaries from the triceps muscle and in its course through it. So this is the axillary vein. So the last superficial vein is the omobrachial vein, this one, or what we call the vena omobrachialis. Vein. So it is formally called the proximal communicating vein of the cephalic vein. It leaves the axillary brachial vein. This is the axillary brachial vein. It leaves it approximately 2 centimeters proximal to the cephalic vein and runs superficially at first on the deltoides muscle. It then arches cranially and medially. It crosses the brachiocephalicus muscle and enters the lateral surface of the external jugular vein, approximately 3 centimeters cranial to the termination of the cephalic vein. The omobrachial vein has no muscular tributaries, but receives small tributaries from the fascia and the skin. So I think that wraps up the superficial veins of the thoracic limb, and the deep superficial uh, veins of the thoracic limb will be discussed by my partner, Psyche.
Let's now dive deeper into the deep veins of the thoracic limb. We have the ulnar, the small median, the brachial, the axillary, and the radial vein. First, we have the ulnar vein. The ulnar vein accompanies its corresponding artery and arises from its union with the palmar branch of the caudal interosseous vein in the carpal canal. It passes proximally in the deep digital flexor muscle, receiving tributaries from most of the caudal antebrachial muscles. It joins the brachial or common interosseous vein in the proximal antebrachium. It may also receive blood from the superficial veins in the forearm, such as the cephalic vein, but mostly of the caudal antebrachial muscles. Next, we have the small median vein. This vein accompanies the corresponding artery. It arises from the superficial palmar venous arc and passes proximally through the carpal canal. And in the middle, the proximal antebrachium is joined by the radial vein and deep antebrachial vein. Proximal to this, it is continued by the brachial vein. The brachial vein receives the transverse cubital, superficial brachial, collateral ulnar, bicipital, and deep brachial veins. It is connected to the cephalic vein by the median cubital vein. So it receives the relatively large common interosseous vein with its ulnar and cranial and caudal interosseous branches. And it receives tributaries from the deep brachial vein and the collateral veins and is continued proximally by the axillary vein. Axillary vein. This vein receives the thoracodorsal cranial circumflex humeral, subscapular, lateral thoracic vein, and external thoracic veins. It is connected to the cephalic vein via the axillobrachial vein. It terminates in the external jugular vein after becoming the subclavian vein at the first rib. Its tributaries are the brachial vein, basilic vein, and cephalic vein. The radial vein is the last of the deep veins of the thoracic limb. It arises from the superficial and deep palmar venous arches. The majority of the venous blood from the superficial arc flows through the anastomosis of the radial vein with the cephalic vein. The small radial vein follows the medocaudal border of the radius covered by the antebrachial fascia. It joins the median vein distal to the deep antebrachial vein. The veins of the forepaw, like the arteries, nerves, and lymphatic vessels, are divided into a dorsal and palmar set. These are not as completely divided into superficial and deep series as are the arteries in the metacarpus, and only a small series exists dorsally and palmarly in the digits. First, let's talk about the axial and abaxial dorsal proper digital veins number 2, 3, 4, and 5. This veins begins in the arcus venosus digitalis formed by the antemosis of the dorsal and palmar sets of proper digital veins. They occur on the axial aspects of the digits number 2 and 3 and on the abaxial aspects of digits 4 and 5. These digital arches collect small tributaries from the digital pads and the corium of the claws. Next, the dorsal common digital veins 1, 2, 3, and 4. These veins continue proximally on the extensor tendons from their formation by the confluence of the dorsal digital veins and the palmar communicating branches. The lateral dorsal common digital vein number 4 runs proximally and joins dorsal common digital vein 3, and the trunk formed by this union continues the axis of the fourth vessel and in turn is joined by the dorsal common digital vein number 2 to form the accessory cephalic vein. The dorsal metacarpal veins number 1, 2, 3, and 4 are delicate veins that lie in the dorsal grooves between the main metacarpal bones. They anastomose distally, with the corresponding dorsal common digital veins at the junction of the middle and distal thirds of the metacarpus and proximally with the poorly formed dorsal rete of the carpus. The blood from the dorsal part of the first digit of the abaxial surface of the second metacarpal drains into the accessory cephalic vein, some 4 cm proximal to the carpus via the dorsal common digital vein 1. This vein collects a tributary from the dorsal venous rete of the carpus. The dorsal venous rete of the carpus. It is a minute, poorly defined plexus of veins on the dorsal surface of the distal row of carpal bones. The dorsal metacarpal veins drain into this carpus, and the accessory cephalic dorsal common digital vein number 1 and the palmar set of veins carry blood from it. The latter include the radial and interosseous veins. The small satellites of the palmar metacarpal arteries are the palmar metacarpal veins 2, 3, and 4. They lie between the fleshy interosseous muscles and run from the superficial palmar venous arc at the level of the metacarpo-phalangeal joints proximal to the anastomosis with the deep palmar venous arc. The deep palmar venous arc lies deep to the origins of the interosseous muscles and follows the distal border of the thick palmar carpal ligaments. Medially, it connects to the radial vein, and laterally, it anastomoses deeply with both the ulnar and the interosseous branches of the common interosseous vein. Usually, a second venous arc exists here, connecting the radial vein with the interosseous branch across the superficial surface of the superficial flexor tendon. So it receives the small cranial circumflex humeral vein cranially and the thoracodorsal vein caudally. So that is it for the major veins and their tributaries for the forelimb. Let us now move on to the hind limb and their major veins and tributaries.
Hi there, Eliza here. Now we have reached the topic of the hind limbs, major veins, and their tributaries, in which we have here the superficial veins, which are commonly used for venipuncture or intravenous process in intravenous access in veterinary procedures, while the deep veins are responsible for draining the oxygenated blood from the lower limbs back to the heart. So here, the following are the large superficial veins of the pelvic limb. We have the vena saphena, saphena lateralis, saphena medialis, the femoralis, and the circumflexa ilium profunda. And all of these veins, except the deep circumflex iliac vein, are commonly used for venipunctures. Okay, the saphenous vein is a vein that runs along the inside of the hind limb. It collects blood from the lower leg and the foot region and joins the femoral vein at the level of the groin. And since it joins the femoral vein at the upper thigh, therefore it is considered as a tributary to the femoral vein. Okay. And the lateral saphenous vein begins by collecting its cranial branch from the flexure surface and the tarsus and its caudal branch from the lateral surface. And in dogs, the lateral saphenous vein receives blood from various tributaries, including the lateral metatarsal veins, the dorsal metatarsal veins, and the lateral digital veins. And these tributaries drains blood from different areas of the lateral aspect of the hind limb into the lateral saphenous vein. Okay, here is a better view of the lateral saphenous vein, or the saphena lateralis. The highlighted part, this one is the saphena lateralis. Okay, Moving on to the medial saphenous vein. It begins by the confluence of its cranial and caudal branches that is medial to the stifle joint. And its cranial branch anastomoses with the cranial branch of the lateral saphenous vein, which runs proximally across the tibialis cranialis muscle and the tibia bones. Then the tributaries, it receives tributaries from the cranial and caudal tibial vein, the ventral saphenous vein, and the dorsal metatarsal veins. And the medial saphenous vein and its tributaries are the satellites of the saphenous artery and its main branches. And actually, in most specimens, a tributary from the gratulis muscle is received by the medial saphenous vein before its termination in the femoral vein, so it lies deep to the thin but dense medial femoral fascia between the caudal belly of the sartorius muscle and the gratulus. And it is also firmly anchored by the fascia between these muscles, and it is a common site for venipuncture. Then it joins the humera then at the apex of the femoral triangle. Here is a better view of the medial saphenous vein, or the vena saphena medialis, here at the right hind limb. Okay, and talking about the femoral vein, this vein is, especially its proximal part, is accessible for venipunctures as it lies in the femoral triangle. And this segment of the vessel lies caudal to the femoral artery and cranial to the small saphenous nerve, and it is sufficiently large and well attached to permit injections without compression. And it receives tributaries from the lateral and medial circumflex femoral vein, deep femoral vein, and the saphenous vein. Next is, here is a better view of the proximal femoral vein, or the V femoralis. You can see it is very much prominent, yes, in the upper thigh. So it is very superficial in its proximal part. Now, the superficial branch of the deep circumflex iliac vein, or the circumflexa ilium profunda, it drains the caudal half of the dorsal 2/3 of the skin of the abdominal wall and the cranial half of the pelvic region and proximal part of the thigh. So the cutaneous veins of the pelvic limb, exclusive of the hindpaw, they are largely tributaries of the superficial veins. However, the skin of the caudal part of this sacropelvic region, the region of the pelvic outlet, and the caudolateral part of the thigh are drained by deeply lying veins. And a cutaneous area over the caudal part of the middle gluteal muscle drains into the cranial gluteal vein, whereas a cutaneous tributary that drains into the terminal part of the lateral caudal vein and perineal veins serves the skin of the pelvic outlet. And a wide caudolateral zone of the skin of the thigh is drained by 3 or more tributaries of a large vein that descends in the biceps femoris muscle and empties into the terminal part of the lateral saphenous vein. And others are formative tributaries of the caudal and deep femoral veins. So, here is the internal iliac vein, interna iliaca. Here's a better view of it. And the external iliac vein. And okay, so that is all for the superficial veins of the pelvic limb.
This is the deep vein of the pelvic limb. We have femoral vein, popliteal vein, and tibial veins. This is the function of cranial tibial vein. It passes between the tibia and fibula, runs deep to the popliteus, and unite with the delicate caudal tibial vein to form the popliteal vein. Tributary is cranial crural group of the muscle, mainly at their proximal end. Popliteal vein function: transverse the popliteal notch of the tibia to enter the popliteal fossa. Its tributary enter the popliteal vein proximal to the joint. A cluster of the vein enter this venous channel at the proximal end of the muscle of the gastrocnemius, where the popliteal vein becomes the femoral vein. Tributary is a medial and lateral tributary from the site of the stipple joint. Distal caudal femoral vein. Receive the lateral spinous vein that is the 3 times larger than any vein distal to the stipple. Tributaries, distal caudal thigh and the proximal caudal crural muscle. Medial caudal femoral vein. 3 mm diameter drain the bicep femoris at the distal end of femoral triangle. The vicinity of entry of the medial spinous vein into it, a muscular tributaries project proximally to it from the gastrocnemius muscle. Receive a tributary from the abductor semembranosus muscle. Proximal caudal femoral vein is the satellite of the most proximal muscular branch of the femoral artery, and this vein arises from the medial surface of proximal half of the gracilis. Tributary is proximal of part of the abductor muscle. Lateral circumflex femoral vein is the largest and the last tributary of the femoral vein, which enters laterally as a satellite of the lateral circumflex artery. It begins in the skin of the proximal lateral surface of the thigh and adjacent dorsally lying gluteal region. Informative tributaries cross the ventral to the middle gluteal muscle near insertion deep to the muscle tensor fasciae latae, and then unite the past the cranial aspect of the neck of the femur and the caudal surface of the origin of the muscle, rectus femoris, to enter the lateral surface of the femoral vein at the vascular lacuna. External iliac vein is approximately 6 mm in diameter and 3 cm long. It arches dorsocranially across the medial surface of the muscle, iliopsoas and ventral to the promontory of the sacrum, and unites with the internal iliac vein to form the common iliac vein. Deep femoral vein is most caudal tributaries are cutaneous branches from the skin of the proximal caudal part of the thigh. Medial circumflex femoral vein emerges from between the pectineus muscle medially and the iliopsoas laterally, where it is continued by the deep femoral vein to the external iliac vein. In its termination, the deep femoral vein receives the large pudendioepigastric vein, which is a common trunk for the caudal epigastric vein, and external pudendal vein. A caudal abdominal vein enters the external iliac vein prior to its union with the internal iliac vein and drains the caudal abdominal wall. Tributaries is the small vein enter the external iliac or deep femoral vein. One enter caudally from the adipose tissue within the pelvic inlet, and the other enters cranially from the rectus abdominis.
The thoracic limb nerves and pathway. The canine nervous system is a complex and intricate network of nerves and cells that work together to control and coordinate various functions in the body. It can be broadly divided into two main components: the central nervous system and the peripheral nervous system. The central nervous system consists of brain and the spinal cord. The brain is responsible for processing sensory information, regulating behavior, and controlling voluntary and involuntary movements. The spinal cord is a long, cylindrical bundle of nerve fibers that run through the spinal canal of the vertebral column. It acts as a relay between the brain and the peripheral nerves and also serves as a center for reflex actions. Next is the peripheral nervous system. The PNS includes all the nerves outside of the central nervous system, extending throughout the body. It is further divided into two subdivisions: the somatic nervous system and the autonomic nervous system. Somatic nervous system is responsible for controlling voluntary movements and transmitting sensory information from the skin, muscle, and joints to the central nervous system. The brachial plexus is part of the somatic nervous system because it controls voluntary movements and conscious sensory perception in the forelimb. It allows dogs to interact with their environment, move muscle voluntarily, and perceive external sensations. Next is the autonomic nervous system. The autonomic nervous system regulates involuntary processes in the body, such as heart rate, digestion, and respiration. It is further divided into the sympathetic and parasympathetic nervous system, which have opposing effects to maintain balance and homeostasis. Now,
Let's focus on the region and pathway of the brachial flexus, which is a crucial component of the canine forelimb nerve supply. The brachial flexus begins as the ventral rami branch of the spinal nerve C5, C6, C7, C8, and P1. These nerve roots emerge from the spinal cord in the neck region and travel downwards towards the shoulder and forelimb. At this point, they come together and form three primary nerve trunks: the cranial upper trunk formed by C5 and C6, the middle trunk formed by C7, and the caudal lower trunk formed by C8 and P1. First one of the brachial flexus is the suprascapular nerve. It is the nerve that innervates intrinsic muscle of the scapular region. The suprascapular nerve arises primarily and occasionally entirely from the sixth cervical nerve. The suprascapular nerve is primarily a muscle nerve to the supraspinatus and infraspinatus muscle. It passes over the scapular notch, innervates the supraspinatus, and continues across the neck of the scapula distal to the end of the spine to enter the infraspinatus. Prior to passing distal to the spine, the nerve sends a small branch to the lateral part of the shoulder joint. Second, it is the subscapular nerve. It is the nerve that innervates intrinsic muscle of the scapular region. The subscapular nerve, or nerve subscapularis, is usually a single but occasionally double nerve that arises from the union of a branch from the 6th and 7th cervical nerves. It usually divides into cranial and caudal parts and entering the medial surface of the distal fifth of the subscapular muscle. Its subscapularis muscle is responsible for medially rotating the shoulder joint and stabilizing the shoulder girdle during movements of the forelimb. Third is the axillary nerve. The axillary nerve arises as a branch from the combined 7th and 8th cervical nerves. It supplies mainly the muscle of the shoulder joint as it curves around the caudoventral border of the subscapular muscle near its distal end. In its intramuscular course, proximo-caudal to the shoulder joint, it divides basically into two portions. One part sends branches to caudal fascicles of the subscapular muscles and completely supply the muscle of teres major. The other portion, accompanied by the caudal circumflex humeral vessels, runs laterally to supply the laterally lying teres minor and deltoideus. Before entering the teres minor, a branch enters the caudal part of the shoulder joint capsule. Next, the fourth is the radial nerve. The radial nerve, radialis, arises from the 7th and 8th cervical and the 1st and 2nd thoracic nerves. The radial nerve is the largest nerve of the brachial flexus. It supplies all the extensor muscle of the elbow, carpal and digital joints, and also the supinator, brachioradialis, and abductor digiti 1 longus muscle. The skin on the cranial portion of the antebrachium and the dorsal surface of the paw is also supplied by the axons of the radial nerve. Moreover, the radial nerve gives off the caudal lateral brachial cutaneous nerve, which supplies the skin covering the lateral head of the triceps muscle. The fifth one is the musculocutaneous nerve. It is the nerve that runs along the medial surface of the thoracic limb. The musculocutaneous nerve arises from the C6, C7, and C8 cervical spinal nerve. Throughout the brachium, the musculocutaneous nerve lies between the biceps brachii, cranially in the brachial vessels caudally. It supplies the coracobrachialis, the biceps brachii, and the brachialis. A branch communicates with the median nerve proximal to the flexor surface of the elbow. The musculocutaneous nerve courses deep to the insertion of the biceps. It supplies the distal end of the brachialis and gives up the medial cutaneous antebrachial nerve, which is usually removed with the skin. This nerve is sensory to the skin on the medial aspect of the forearm. The sixth one is the median nerve, a nerve that runs along the medial surface of the thoracic limb. The median nerve, or medianus, arises primarily from the eighth cervical nerve by a lateral root, radix lateralis, and first thoracic nerve by a medial root, radix medialis, with small contribution from the seventh cervical and second thoracic spinal nerves. The median and ulnar nerves in the forearm lie caudal to the brachial artery and vein, where they are loosely joined by fascia. The median nerve is cranial in relation to the ulnar nerve. The median nerve does not give off any branches proximal to the elbow joint. It crosses the flexure surface of the elbow joint, cranial to the medial epicondyle. The median nerve passes deep to the pronator teres and enters the large caudal group of the flexure muscles located in the antebrachium. It gives muscular branches to the pronator teres, pronator quadratus, flexor carpi radialis, and flexor digitorum superficialis, and the radial head of the flexor digitorum profundus. It also sends axon to the deep part of the humeral head to the flexor digitorum profundus, and a small articular branch to the medial aspect of the elbow joint. Next is the ulnar nerve. The ulnar nerve, ulnaris, arises in close association with the radial and medial nerves from the eighth cervical and the first and second thoracic nerves. The ulnar nerves, the caudal division of the common tract, separates from the median nerve in the distal arm and crosses the elbow caudal to the medial epicondyle of the humerus. The caudal cutaneous antebrachial nerves leaves the ulnar nerve the middle of the arm and runs caudodistally across the medial surface of the triceps and olecranon. This supplies the skin of the distal medial aspect of the brachium and the caudal aspect of the antebrachium. The median and ulnar nerves supply the flexor muscle of the carpus and digits. Next is the nerves to extrinsic muscle of the thoracic limb. The first one is the thoracodorsal nerve. The nerves to intrinsic muscle of the thoracic limb is the thoracodorsal nerve or thoracoldorsalis that arises primarily from the eighth cervical nerve with contribution from the first thoracic or the seventh cervical nerve or both. It is the motor nerve to the latissimus dorsi. It runs caudodorsad in close relation to the thoracodorsal vessels on the medial surface of the muscle. The thoracodorsal nerve does not have any cutaneous branches. Next is the cranial pectoral nerve. The cranial pectoral nerves, or pectoralis cranialis, supply the superficial pectoral muscle. They are irregular in number and origin, but usually arise as two branches from the 6th, 7th, and 8th cervical nerves. They have formerly been included under the term ventral thoracic nerves. They do not give off any continuous branches. Next one is the lateral thoracic nerve. The lateral thoracic nerve, thoracisus lateralis, is composed of axons that come primarily from the 8th cervical and 1st thoracic nerves. These long nerves give rise to branches that supply the deep pectoral muscle and is the sole motor supply to the continuous stroncy muscle, and in male, the cranial prepotial muscle. At first, the nerve accompanies the lateral thoracic artery and vein. It lies between the adjacent borders of the latissimus dorsi and deep pectoral muscle after passing medial to the axillary lymph nodes. It intermingles with the lateral continuous branches of the thoracic and cranial lumbar nerves, but does not contain any continuous afferent action from C8, T1, or T2 from the brachial plexus. Next is the long thoracic nerve. The long thoracic nerve, thoracisus longus, usually arises from the branchial branch of the 7th cervical nerve before it branches to aid in forming the brachial plexus. It runs largely horizontally on the superficial surface of the thoracic portion of the serratus ventralis cervices, which it supplies. Next is the nerves of the forearm and paw, or the manus. The first one is the radial nerve of the forearm. The radial nerve supplies the extensor of the elbow, carpus, and digital joints. The radial nerve innervates the extensor carpi radialis, the common digital extensor, the supinator, the lateral digital extensor, the abductor digiti 1 longus, and the ulnaris lateralis, as seen in the picture in the slides. Next is the median nerve of the forearm. The median nerve runs distally into the antebrachium with the brachial artery. It innervates the pronator teres, the pronator quadratus, the lexor carpi radialis, the superficial digital lexor, and the radial heads and parts of the humeral and ulnar heads of the deep digital lexor. The median nerve passes through the carpal canal with the median artery and branches to supply sensory innervation to the palmar surface of the forepaw. The last one is the ulnar nerve of the forearm. The ulnar nerve diverges caudally from the median nerve at the distal curve of the arm. At this point, the caudal cutaneous antebrachial nerve arises from the ulnar. The ulnar nerves enters the antebrachial muscle caudal to the medial epicondyle of the humerus and is distributed to the flexor carpi ulnaris and parts of the ulnar and humeral heads of the deep digital flexor. In the middle of the antebrachium, the dorsal branch of the ulnar nerve arises and becomes subcutaneous on the lateral surface. It is distributed to the lateral surface of the metacarpus and the fifth digits. So that's the end of the nerve pathway of the forelimb and forepaw of the canine.
Hello everyone, my name is Nick and I'm here to continue off of Chilo's report about the dog's nerves of their limbs. So in my case, I'll be talking about the nerves of the pelvic limb. So a brief refresher, what exactly are nerves? What are the deal? In my simplest form of understanding, the nerves are basically the wires that is found throughout the body. It carries information back and forth to the brain and towards the body. So information is gained via stimuli from the body or the animal surroundings or circumstance. That information then travels through the veins to the brain, to which then the brain sends out commands throughout the body and initiates reactions relative to that environment or circumstance. So, now that that's out of the box, let's continue. First and foremost, I want to talk about the lumbosacral plexus. So basically, the lumbosacral plexus is a series of nerves or a network of nerves found in the lumbar or sacral region of the spine. The lumbar sacral plexus is a network of nerves that originates from the spinal nerves in the lower back region or the lumbar region and extends into the sacral region. It plays a crucial role in controlling and coordinating movement and sensation in the hind limbs and pelvic area. This is because most of the major veins that is found in the pelvic limb originates or forms from the lumbosacral plexus. The main nerves forming the lumbosacral plexus include the lumbar nerves L4 to L7 and the first three sacral nerves S1 to S3. These nerves branch and merge to form various smaller nerves that innervate the muscles, joints, and skin of the hind limbs, tail, and perineal region. So this is a graphic of the spinal root origins of the major nerves of the lumbosacral plexus. So as you can see here, we can see the superficial fibular nerve, which originates from the sacral 1 to sacral 3, the dorsal nerve of the penis, which originates from the sacral 1 to the sacral 2, then the caudal cutaneous femoral nerve, the proximal caudal cutaneous sural nerve, the lateral cutaneous sural nerve, distal caudal cutaneous, etc., etc. So most of these nerves here are basically the major nerves of the pelvic limb. Let's move on to the nerves found in the pelvic limb. So in our first example here, we have the femoral nerve. It originates from the fourth to fifth lumbar. It begins its course in the abdomen by passing through psoas major muscle. It innervates the anterior thigh muscles that flex the hip joint or the pectineus, iliacus, and sartorius, and extend the knee, which is the quadratus femoris, the rectus femoris, vastus lateralis, vastus medialis, and vastus intermedius. It supplies the cutaneous branches to the anteromedial thigh or the anterior cutaneous branches of the femoral nerve, and the medial side of the leg and foot or the saphenous nerve. The saphenous nerve. After arriving from the femoral nerve, the saphenous nerve then travels through the inside of the limb, passing through the adductor canal. It then continues its pathway down to the lower leg and foot, providing sensory innervation to the skin along the inner aspect of the limb and the foot pad. So, to get a more specific origin for this venous nerve, we can go back to the previous photos here. I think it should be here. Okay. Yeah. Okay. So this basically the sphenius nerve originates from it branches out from the femoral nerve, and the femoral nerve originates from the fourth to fifth lumbar. So that's basically the sphenius nerve's origin. So the next nerve in the list is the sciatic nerve. It originates from the sixth to seventh lumbar and to also the first sacral uh, spinal vein, as spinal nerve. It innervates the muscles of the posterior thigh, which includes the bostis femoris, the semimembranosus, and semitendinosus, and the hamstring portion of the adductor magnus, the remaining portion of which is supplied by the obturator nerve. It indirectly innervates via its terminal branches the skin of the lateral leg heel and both the dorsal and plantar surface of the foot. The obturator nerve originates from the fourth to sixth lumbar uh, spinal nerve. It innervates the muscles of the medial compartment of the thigh or the obturator externus, adductor longus, adductor brevis, adductor magnus, and gluteus. After its formation, the obturator nerve descends through the fibers of the psoas major and emerges from its medial border. It then travels posteriorly to the common iliac arteries and laterally along the pelvic wall or towards the obturator foramen of the pelvis. Our next nerve is the, uh, the tibial nerve. It starts from the sixth lumbar, seventh lumbar, and also the first sacral. To my understanding, the tibial nerve is actually a branch of the obturator nerve, so it makes sense that they would carry the same origins. A major peripheral nerve of the lower limb, it has several cutaneous and motor functions in the leg and foot. Tibial nerve is a branch of the sciatic nerve and arises at the apex of the popliteal fossa. It travels through the popliteal fossa, giving off branches to muscles in the superficial posterior compartment of the leg. In our next nerve, we have the common fibular or peroneal nerve. It follows a pathway down the hind limb, passing through the popliteal fossa, same with the tibia, and the space behind the knee. And continuing down to the lower leg and foot along its course, it supplies motor and sensory innervation to various muscles and skin areas in the hind limb. Superficial peroneal nerve arises alongside the deep fibular nerve at the bifurcation of the common fibular nerve below the head of the fibula and in the proximal part of the fibularis longus muscle. So in this photo here, you can see that this superficial peroneal nerve actually originates from the, I believe it's the sciatic nerve. Yeah, the sciatic nerve. So it branches out from the sciatic nerve. Next up, we have the deep peroneal nerve. It arises from the fourth to sixth lumbar of the spinal nerve roots and uh, and runs along the lateral aspect of the hind limb, providing innervation to the muscles and skin of the dorsal part of the paw. It's responsible for controlling dorsiflexion of the paw and plays a role in maintaining normal gait and coordination. So next up is also a nerve at the lower region of the pelvic limb called the lateral plantar nerve. It arises from the tibial nerve, which is a branch of the sciatic nerve, and it runs down the medial side of the hock, then runs the back of the metatarsus to the foot. And the other one, which is the medial plantar nerve, it's in the same general area as the lateral plantar nerve, but it also has the same origin. It arises from the tibial nerve as well and follows a more medial path down the dog's leg. It innervates the muscles and the skin on the plantar surface of foot. So yeah, that's about it. That is the report for my nerves of the pelvic limb. Moving on to the pelvis. I'm done. Hello, I'm done. Yeah, yeah, yeah.
Dan nakanek.
Yeah, 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 yeah. Everyone, my name is Nick, and I'm here to continue off of Chila's report about the dog's nerves of their limbs. So in my case, I'll be talking about the nerves of the pelvic limbs. So a brief refresher, what exactly are nerves? What are the deal? In my simplest form of understanding, the nerves are basically the wires that is found throughout the body. It carries information back and forth to the brain and towards the body. So information is gained via stimuli from the body or the animal surroundings or circumstance. That information then travels through the veins to the brain, to which then the brain sends out commands throughout the body and initiates reactions relative to that uh, environment or circumstance. So, out of the out of the box, let's continue. First and foremost, I want to talk about the lumbosacral plexus. So basically, the lumbosacral plexus is a series of nerves or a network of nerves found in the uh, lumbar or sacral region of the spine. The lumbar sacral plexus is a network of nerves that originates from the spinal nerves in the lower back region or the lumbar region and extends into the sacral region. It plays a crucial role in controlling and coordinating movement and sensation in the hind limbs and pelvic area. This is because most of the major veins that is found in the pelvic limb originates or forms from the lumbosacral plexus. The main nerves forming the lumbosacral plexus include the lumbar nerves L4 to L7 and the first three sacral nerves S1 to S3. These nerves branch and merge to form various smaller nerves that innervate the muscles, joints, and skin of the hind limbs, tail, and perineal region. So this is a graphic of the spinal root origins of the major nerves of the lumbosacral plexus. So as you can see here, we can see the superficial fibular nerve, which originates from the sacral 1 2 to sacral 3, the dorsal nerve of the penis, which originates from the sacral 1 to the sacral 2, then the caudal cutaneous femoral nerve, the proximal caudal cutaneous sural nerve, the lateral cutaneous sural nerve, distal caudal cutaneous, etc., etc. So most of this these nerves here are basically the major nerves of the pelvic limb. Let's move on to the nerves found in the pelvic limb. So in our first example here, we have the femoral nerve. It originates from the fourth to fifth lumbar. The, it begins its course in the abdomen by passing through psoas major muscle. It innervates the anterior thigh muscles that flex the hip joint or the pectineus, iliacus, and sartorius, and extend the knee, which is the quadratus femoris, the rectus femoris, vastus lateralis, vastus medialis, and vastus intermedius. It supplies the cutaneous branches to the anteromedial thigh or the anterior cutaneous branches of the femoral nerve, and the medial side of the leg and foot or the saphenous nerve. The saphenous nerve. After arriving from the femoral nerve, the saphenous nerve then travels through the inside of the limb, passing through the adductor canal. It then continues its pathway down to the lower leg and foot, providing sensory innervation to the skin along the inner aspect of the limb and the foot pad. So, to get a more specific origin for this saphenous nerve, we can go back to the previous photos here. I think it should be here. Okay. Yeah. Okay. So this basically the saphenous nerve originates from it branches out from the femoral nerve, and the femoral nerve originates from the fourth to fifth lumbar. So that's basically the saphenous nerve's origin. So the next nerve in the list is the sciatic nerve. It originates from the sixth to seventh lumbar and to also the first sacral uh, spinal vein, as spinal nerve. It innervates the muscles of the posterior thigh, which includes the bostis femoris, the semimembranosus, and semitendinosus, and the hamstring portion of the adductor magnus, the remaining portion of which is supplied by the obturator nerve. It indirectly innervates via its terminal branches the skin of the lateral leg heel and both the dorsal and plantar surface of the foot. The obturator nerve originates from the fourth to sixth lumbar spinal nerve. It innervates the muscles of the medial compartment of the thigh or the obturator externus, adductor longus, adductor brevis, adductor magnus, and gluteus. After its formation, the obturator nerve descends through the fibers of the psoas major and emerges from its medial border. It then travels posteriorly to the common iliac arteries and laterally along the pelvic wall or towards the obturator foramen of the pelvis. Our next nerve is the, uh, the tibial nerve. It starts from the sixth lumbar, seventh lumbar, and also the first sacral. To my understanding, the tibial nerve is actually a branch of the obturator nerve, so it makes sense that they would carry the same origins. A major peripheral nerve of the lower limb. It has several cutaneous and motor functions in the leg and foot. Tibial nerve is a branch of the sciatic nerve and arises at the apex of the popliteal fossa. It travels through the popliteal fossa, giving off branches to muscles in the superficial posterior compartment of the leg. In our next nerve, we have the common fibular or peroneal nerve. It follows a pathway down the hind limb, passing through the popliteal fossa, same with the tibia, and the space behind the knee. And continuing down to the lower leg and foot along its course, it supplies motor and sensory innervation to various muscles and skin areas in the hind limb. Superficial peroneal nerve arises alongside the deep fibular nerve at the bifurcation of the common fibular nerve below the head of the fibula and in the proximal part of the fibularis longus muscle. So in this photo here, you can see that the superficial peroneal nerve actually originates from I believe it's the sciatic nerve. Yeah, the sciatic nerve. So it branches out from the sciatic nerve. Next up, we have the deep peroneal nerve. It arises from the fourth to sixth lumbar of the spinal nerve roots and uh, and runs along the lateral aspect of the hind limb, providing innervation to the muscles and skin of the dorsal part of the paw. It's responsible for controlling dorsiflexion of the paw and plays a role in maintaining normal gait and coordination. So next up is also a nerve at the lower region of the pelvic limb called the lateral plantar nerve. It arises from the tibial nerve, which is a branch of the sciatic nerve, and it runs down the medial side of the hock, then runs the back of the metatarsus to the foot. And the other one, which is the medial plantar nerve, it's in the same general area as the lateral plantar nerve, but it also has the same origin. It arises from the tibial nerve as well and follows a more medial path down the dog's leg. It innervates the muscles and the skin on the plantar surface of foot. So yeah, that's about it. That is the report for my nerves of the pelvic limb.